So today we'll look at this question called towers from the cses problem set. So it says that we are given n cubes and they are given in certain order, and the order is very important because what you need to do is you need to put these n cubes and build towers using them, right? But you need to put those cubes in like the same order in which it's given in the question, and also you need to put them on top of each other. Like if you put it on top of each other, then the upper cube, right, like if this is one cube and this is another, so this upper cube, this must be smaller than the lower cube. Okay. So you can always either place the cube on top of an existing tower, or you can begin a new tower, right? So if this is not smaller, like if this is a larger cube like this, then you can, like, you can't place it here, and you will make a new tower like this, right? Okay. So now the question is, what is the minimum possible number of towers? So they're just asking that what is the minimum number of towers in which you can arrange all these cubes. Okay. So let's just take a test case. So the first test case is 3, 8, 2, 1, 5, right? So this says that let's say this is, like, you're starting with this. So uh, you put 3 first, right? This is your 3. Okay, then you put 8. Okay, now you have 2. So tell me one thing, where will you try to put 2? Now see, the problem is if I try to put 2 here, okay, then 2 comes here, 1 comes here, and then 5 I can't place here, I can't place here, I have to make a new tower, right? So this is not the right strategy. Right strategy is to fill the lowest or the smallest element. So like if I put 2 here, right, and then I put 1, okay, and then I put 5 here, so I'm just done in 2 towers, right? Whereas if this arrangement was not right and I was putting 5 here, right, sorry, not here, sorry, if I was putting 2 here, if I was putting 2 here, then it took me 3 towers, whereas it's taking only 2 towers in this case, which means that we always need to choose this the smallest element. So I'll tell you the idea. The idea to solve this is you basically take a multiset, like the implementation I'm explaining. So you take a multiset, right? I hope you know what a multiset is. So basically in a set what happens, elements are arranged in order and they're unique elements, right? Multiset is not, like, it's completely like a set, but it does not have unique elements, right? It can have repeated elements, but they are differently sorted as it happens in a set, right? So what you will do is, see, the implementation is somewhat like this, that you iterate throughout, right? So you just go for int I equal to 0, I less than n, I plus plus, right? But then what you do is, uh, you simply, like, if towers, like you make a towers array, let's say, and you check that, see if, like, it's the first element, that is if my size is 0, okay, then what I'll do, I'll just simply insert, I'll insert towers dot insert a of I, right? Okay, so that is only for the first element. Okay, then after that what happens, if the element that I'm getting now, okay, so if that is, like, what do I need to find? I need to find some particular cube that is just greater than that, right? So basically it has to be greater, because if it's not greater I can't put, I have to make a new tower, right? But it has to be the smallest element, it has to be the smallest element that is greater than equal to x, right? That is, or greater than equal to a of I, which, like, what does this thing mean? Okay, not equal to, sorry, greater than a of I. So this is nothing but upper bound, right? So we will just take some variable, let's say some iterator. So you'll just mention that auto it is equal to, uh, so it's like you have that particular multiset. So we'll just do s dot begin, s dot end, right? From here you will get the upper bound, like basically upper bound of this thing, right? And then once you get the upper bound, right? So if this upper bound exists, right, then there's a case, and if it doesn't exist, then there's a case. So like if it doesn't exist, that is your it is equal to s dot end, right? If it does not exist, then what we'll do is uh, like see if the upper bound doesn't exist, we have to form a new tower, right? So we'll simply do towers dot insert a of I, right? But let's say if it exists, right, then what you will do, then see, like if I had this 3 comma 8, right, and then when I inserted 2 above this, so what I did, I removed this. So basically this kind of became 2 comma 8 because now I don't have this 3 anymore. Now above this 3 I have 2, and if I want to put anything here, right, that needs to be smaller than this 2. So basically this 3 like is completely irrelevant, and I need to store 2, right? So basically what I'll do is I'll remove the upper bound, so which I've got some upper bound, right? So I'll simply remove that upper bound. You will remove that particular, you will erase that particular iterator whatever you've got, right? And you will insert, like this is the else part I'm saying, this is the else part. So and I'll insert, and what am I inserting? I'm inserting the current one, right? And so what is going to be answer? It is nothing but towers dot size, whatever number of towers you have made, right? How many insertions are there? So that will be your answer. Okay, I hope you have understood. Thank you.